Before starting with it, subscribe the channel, share it with your friends and hit the bell icon to get the notification. In this, which chemical properties we are going to deal with, let's just look into it. First is halogenation of phenols. Next, nitration of phenol, sulfonation of phenol, Reimer-Tiemann reaction, Kolbe reaction, oxidation of phenols, catalytic hydrogenation of phenols, and reduction of phenols. In which we are going to deal with bromination of phenol. When phenol is treated with aqueous solution of bromine, it gives 2,4,6-tribromophenol, which is a white precipitate. Let's see how the reaction is taking place. Here this is phenol. When it is treated with aqueous solution of bromine, we find formation of 2,4,6-tribromophenol is taking place and HBr is removed. The product of the reaction depends on the nature of the solvent used for the reaction. Chlorine reacts in the same way. When reaction is carried out with bromine in solvents of low polarity, then water such as carbon tetrachloride, chloroform or carbon disulfide, and at a low temperature, that is 273 Kelvin, mixture of ortho and parabromophenol is formed. This is phenol. When it is treated with bromine in the presence of low polarity solvent, then water, which is CS2 here, carbon disulfide, at 273 Kelvin forms orthobromophenol and parabromophenol. Hydrogen atom of benzene ring of phenol are substituted by halogen. With dilute nitric acid at low temperature, that is 298 Kelvin, phenol yields a mixture of ortho and para-nitrophenols. Here is the reaction. Here, nitric acid, that is HNO3, is written as HONO2 for the convenience to understand the reaction. The reaction is taking place at a room temperature, and let's see how the formation of product is taking place. First it forms orthonitrophenol and para-nitrophenol. Ortho and para isomers are separated by steam distillation. Going to see nitration of phenols with concentrated nitric acid. Phenol is converted to 2,4,6-trinitrophenol, which is said to be picric acid. The yield of the reaction is poor. Phenol treated with concentrated nitric acid in the presence of concentrated H2SO4, the mixture of these two concentrated acids, that is concentrated nitric acid and concentrated sulfuric acid, is said to be nitrating mixture. Phenol, when treated with such nitrating mixture, gives 2,4,6-trinitrophenol, which is said to be picric acid. Sulfonation of phenol. When phenol is treated with concentrated H2SO4 at room temperature 298 Kelvin, it gives orthophenol sulfonic acid, that is 2-hydroxybenzene sulfonic acid, as the major product. Here it is phenol. H2SO4 is written in this way as HOSO3H for the reaction to be understood well. As the reaction is taking place at room temperature, the product obtained is in such a way to form orthophenol sulfonic acid or 2-hydroxybenzene sulfonic acid. Substitution of hydrogen atom of benzene ring of phenol by SO3H group is called sulfonation of phenol. Let's see sulfonation of phenol with concentrated H2SO4 at 373 Kelvin. It gives paraphenol sulfonic acid, that is 4-hydroxybenzene sulfonic acid, as the major product. As we can see here, phenol, when treated with concentrated H2SO4 at 373 Kelvin, forms paraphenol sulfonic acid or 4-hydroxybenzene sulfonic acid. Substitution of hydrogen atom of benzene ring of phenol by SO3H group is called sulfonation of phenol. In the presence of NaOH reacts with chloroform to give salicylaldehyde. Let's see how this is formed. Phenol, when treated with chloroform in aqueous NaOH solution, first forms an intermediate and removal of water molecule is taking place. The intermediate substituted benzyl chloride is hydrolyzed in the presence of alkali to produce salicylaldehyde. Let's see. Intermediate reacts with NaOH and forms undergoes hydrolysis to give salicylaldehyde. The orthoisomer is the major product which can be separated from paraisomer by steam distillation. On treating phenol with chloroform in the presence of sodium hydroxide, CHO group is introduced at ortho position of benzene ring. This reaction is known as Reimer-Diamond reaction. The predominance of orthoisomer is due to its greater stability by intramolecular hydrogen bonding. Kolbe's reaction. Phenol reacts with NaOH to give sodium phenoxide. It undergoes electrophilic substitution with carbon dioxide, which is a weak electrophile, to give orthohydroxybenzoic acid. Phenol reacts with NaOH to give sodium phenoxide. Phenoxide ion generated is even more reactive than phenol towards electrophilic aromatic substitution reaction. Hence it undergoes electrophilic substitution with carbon dioxide, which is a weak electrophile. Giving rise to formation of 2-hydroxybenzoic acid, that is salicylic acid. Orthohydroxybenzoic acid is formed as the major reaction product at low temperature, while para-hydroxybenzoic acid at high temperature. Oxidation of phenol with chromic acid produces a conjugated diketone known as benzoquinone, a conjugated ketone. Here this is phenol. When it is treated with Na2Cr2O7 and H2SO4, it forms benzoquinone. In the presence of air, phenols are slowly oxidized to dark colored mixtures containing quinones. Let's talk about catalytic hydrogenation of phenol. Mixture of vapors of phenol and hydrogen is passed over nickel catalyst at 433 Kelvin. Phenol undergoes catalytic hydrogenation at 433 Kelvin to form cyclohexanol. Phenol is converted to cyclohexanol on catalytic hydrogenation. Test. Phenol is reduced to benzene on heating with zinc dust. Phenol, when treated with zinc, produces benzene plus ZNO is removed. Then phenol is heated with zinc dust, it gives benzene. It well. Then subscribe my channel, comment on it, like it and share it with your friends. Hit the bell icon to get the latest updates. Thank you.